So up in that top part of the sensitivity report, there's another thing that we need to look at that concerns the objective function. We're going to look at the thing called the reduced cost. And so what happens is, suppose that we got an optimal solution that indicated that we don't produce any space rays, so S equals 0. We did not get that, right? But just for a moment, assume that's what happened. We could then ask, how much would the profit coefficient have to be increased before it would be worth it to produce space rays as part of the optimal solution? The answer to that question is called the reduced cost. Now, the column in Excel shows that the reduced cost for both of our variables, S and P, was 0. This is always going to be the case with any variable that has a positive value on it, right? If it's only going to happen if there's a 0 there. So reduced cost only show up if they're non-zero. They can be negative when the variable is 0 in the optimal solution. So if we go to the spreadsheet here, we see the reduced cost for both of these in the sensitivity report is 0 because we're producing both space rays and phasors. So now let's go back and change this to, let's change the objective function coefficient to space rays from an 8 down to $2. That's outside the range, right? So I don't know what's going to happen. I could get a different solution point. So I'm going to copy this guy over, move or copy, create, move to the end, and I'm saying 0 these guys out and put a 2 here. Alright, so this is what I've changed. So maybe what I'll do is make it yellow, just so we know that that's what I changed. And then I want to go to Data, Solver. It's set up again because I copied it from over there. Click Solve, and I want to kick out a sensitivity report for this. It found the solution, and click OK. So now notice that we're not producing any space rays, but we are producing 600 lots of phasors. Notice now too that we no longer use up all of the pounds of plastic, so we have changed to a different corner point, 0, 600. So go back to that graph and see which one that was. So now let's look at the sensitivity report for this guy, and we see that now when we have a 0 here, we get a reduced cost of negative 1.75. Right? So I explained that here. Let's look at it. So this is what we get. Right? The optimal solution now is 0 space rays, 600 phasors, lots of phasors, for $3,000. The reduced cost is negative $1.75. So increasing the profit by $1.75 is the same as reducing the cost component by $1.75. That's why we got a negative sign there. So the profit for the space rays would have to go up to $2 plus $1.75 is $3.75 before it becomes economically feasible to produce space rays. That $3.75 should look familiar to you. It was the low end of the range of optimality when we had 8 and 5 for the objective function coefficients, right? So another way to look at reduced cost is if I left the profit for space rays at $2 and was forced to produce 1 unit, 1 dozen, of space rays, what effect would that have on my profit? I could add another constraint, S is greater than or equal to 1, resolve it, and it should knock my profit down by $1.75, that negative 1.75 in the reduced cost, right? So I would go from $3,000 to $1.75 less than that. So let's try that and see what happens. So I'm going to, I guess I'll copy this one. Create a copy, move to the end. And now I want to, I say force space ray production. So I need to say S, there's a 0, is greater than or equal to 1. Right, and I have my Excel set up so it follows it down. So I've added the constraint here. I have to, when I go, I also have to notice it's not meeting this constraint because I solved it without it. When I go into here, the solver dialog, I need to add another constraint. Pick the left-hand side. That's some product greater than or equal to 1. Click OK. Solve it. Keep the solution. OK. So now I'm making one lot. We're doing a fraction here because I want to use up all of my labor. And I'm $1.75 short or less than what I had before. Right? And again, this is not a problem because we're dealing with fractions and decimals in linear programming. So that's what the reduced cost does for us.